Hello and welcome back. Today on the bench are the bloody 50 watt amplifiers, 50 watt monoblock. Where do you call it, amplifiers? And I was making a video about testing the amplifiers for unconditional stability when the power supply developed a fault, and all sorts of other interesting things happened. This video might be a little bit all over the shop. Well, what's new there? Because like it's sort of, you know, all over the fucking place as usual. Anyway, onwards and upwards. So for all this testing of frequency testing and whatnot, the delay start in the power supply has started playing up. It's played up once or twice before. Tried changing the valve. That sort of fixed it for a bit, but it's still being just unpredictable, which is no good, because basically, I mean, we've got 500 volts HT. These two big resistors come off. Basically, your winding comes off the transformer through a resistor, and then basically after about 20 seconds, this relay kicks in. This relay kicks in and basically shunts out those resistors. So what was happening was, it was like, you know, 30 seconds, 40 seconds, and the HT is dropping, obviously, because the valves are warming up and everything. And after testing the delay valves, I got 3 of those, like octal types. Yeah, it's just, I decided to go with the silicon solution. And that is, if I can find it, yeah, that's using an MJF 122G, which I think is very similar to a TIP 122, and it's basically a Darlington resistor, 100 volt Darlington resistor, so there's like 2 resistors in one, so loads of current gain. And all it is a very simple RC delay circuit. So we've got a positive voltage here, which is 24 volts, which is needed to switch K2. The relay, I don't know why relays are called Ks, go figure. Well, you can't call them an R, can you? Because otherwise you get R. Anyway, I digress. Anyway, positive voltage there goes through a resistor into a capacitor, and there's your RC time constant. I've also got a resistor across the 220U capacitor. That sort of slows down the delay time as well. So by playing around with these values, you can alter your delay time. The output of that, as it were, goes through this Zener. Once these 12 volts across this Zener, then that turns on the Darlington resistor, turning on in turn K2, and that is going to be hopefully a lot more reliable than the delay valve. However, what I'm going to do, I'm going to still put the delay valve in, but it just won't be connected, so everything is just going to be mounted onto this base here, and then this is the base for the other relay that sort of goes on top like that. So at the moment I've just sort of tacked it together just to do a bit of testing. I did hit a snag though yesterday. Me pot of 10 volt and above Zener diodes has gone missing, and so I ended up, like, you know, just stopped. I couldn't continue. However, can't find the tub, but I did find a 12 volt Zener and an old PCB, so hopefully that isn't knackered and we can get this thing up and going, continue testing, etc. Right, well, that's all cobbled together. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 18, 19, 20, 21, 22, 23, 24. Right, I need to change this resistor across this capacitor. Right, let's try this then. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. About 13 seconds. That's grand. That'll do me. Right, I shall build it properly, get it on the amplifier, done a continue test. Then I can then I can continue testing. Just a word about this delay start that I had in before this one. It's worked fine for years. However, I think all the switching on and off recently that I've done when testing has not done it much good at all. Also, I had some drop-in resistors in there to drop the voltage to the heaters on the delay valve. Those resistors were incorrect, and also one of them had a dodgy lead. It was a loose lead, which was also causing problems. I'm troubleshooting this bloody delay circuit here because I wired it all together, fitted it in, and the K2 wouldn't latch. I'm going to point you at the oscilloscope screen. Right, I'm on the collector of the Darlington transistor. Power on. See, we're not reading out. Now it's latched, or is it? Yeah, it's latched now, and I don't know if you can see. I'll turn the intensity up. I hope you can see that we're getting all sorts of crap, parasitic oscillation. I need a capacitor from somewhere to somewhere, not sure where. Well, I tried a 47 picofarad capacitor across the collector and emitter. That's the circuit there, very simple. 57k into a 220 microfarad capacitor. It's got 100k across that capacitor to drain it, and also it sort of has a part in fixing the delay time. 12 volt Zener into the MJF 122G. The collector is connected to the coil of the K2 of the relay, and we've got a back EMF diode across the coil of the relay. So what I think is happening, the coil obviously has some inductance, and then so there's some sort of resonance going off somewhere. So the other thing I can try is a capacitor across the coil, so I'll try that. Oh, success of sorts. Turn it on. This is monitoring the base voltage of the Darlington. As you can see, it's starting to ramp up. Switches on. The where do you call it? The relay is latched. Well, latched, turned on. As you can see, we've got 1.185 volts there, and as you can see from the trace on the oscilloscope, I'm monitoring the base. Noise is a lot less. I'll just move you on to the collector, which is what we were looking at yesterday, and the noise is a lot less. And now I will tell you how I did that. So after I put a post on the forum that I'm on, and the lads suggested various things like not using this circuit, saying it's crap, and to use a SMIT trigger instead. That's not the IC based SMIT trigger, that's using dedicated transistors, you know, say 2 transistors. Another thing that was suggested was to put a resistor from the base to the emitter. I tried quite a few resistor types, not really knowing an equation or whatever so that I could figure out the exact value, and basically what that did, that pulled the base voltage down. Let me just turn this off. So that pulled the base voltage down too much. One other thing that was mentioned was the Zener. So I was using something like one of this big sort of 5 watt Zeners, and somebody mentioned on there about the leakage of you know, the reverse leakage of the Zener could probably be an issue. So after trying various resistors and also trying a RC filter, because I found that the bass was oscillating at about 200 kilohertz, and I set that 3 dB point of the RC filter to 150 kilohertz. That did reduce it somewhat. In the end I swapped the Zener out and the results are as you see. So in this circuit, while it isn't the best circuit, it would have probably been better to use a thyristor, but I haven't got any thyristors at the moment. If you change the Zener, that can change things a hell of a lot. The noise really isn't an issue in this application because this circuit isn't grounded to the main ground or anything like that. However, the unstable base voltage was an issue going forward. And the other thing I also found was, because I've got a LED indicator for when this comes on, so for when we've got full HT, to indicate that you've got full HT, I found that because the base voltage of this Darlington is marginal at best, like 1.1, 1.2 volts as you saw, the LED was pulling the voltage down a tad. I don't know quite why, because it's on the collector, and yeah, so I don't know. Anyway, it seems to be working. Finally I can put the bugger back in and get back to testing. Having finally sorted the delay part of this circuit here, I put it back in, I think for about the 4th time, and then I thought, right, well I best check that this relay that goes in there is actually switching out these big resistors. It's doing that one but not this one. So despite having checked my work quite a few times and having worked on this I think every morning for about a week, the fucker still isn't right, which is most perturbing. I'm trying to get my motorbike fixed as well at the same time, so I could really do without this crap. So it's got to come out again, and this time it's going to be right. What I've found is that when I make something like this, put it together, when I do it the first time, it's usually well put together, all the soldering's right and all the rest of it. And the problem is that when I start to when I start to fault find it and sort of messing about unsoldering things and buggering about with it over a period of time, then all the work that was sort of bang on before gets undone, and it's just ends up not being as good as it could be. So I've taken the whole bloody thing apart and I shall put it all back together again. Okie dokie. I had wired it up correctly, despite, and this is where counting pins on valve bases can be problematic. So usually a pin out, you look at it from the bottom, so that would be, we've got like a key here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And obviously when it's like that way, flipped over 180 degrees, that would be 1, 2, 3, 4, etc. So yesterday I've got me meter on continuity, so I knew I got one pin right, so we should have here 1, 2, 3, 4, 5, 6, 7 and 9 should be joined. Beep, correct. So where are we again? 1, 2, 3, 4, 5, 6 and 11 should be joined. And so I was buzzing it out, as you can see I'm doing. No continuity. Well, if I flip it round, there's pin 6. And look at that, look. So that's my soldering there, that hasn't soldered on there properly, and that's why I wasn't getting any continuity. That was a fuck up there. I usually look at my joints through a magnifying glass because my eyesight isn't brilliant. Right, I shall rectify that, put it back together. Hopefully this will be for the last time. Well, that's it all wired back in. Just got it on bench supply at the moment. Just waiting for a click. And there we go, there's a click. Now to test whether it's shunted out those two resistors. So where are we? Got to get in there. This isn't live, thankfully, so I'll get my probe down in there. So that's at one end. We should get a beep if I remember to turn the meter on. Beep, lovely. And then the other one is floating about because I was testing it yesterday. Hurrah. Right, now off. No continuity. Nearly there, lads. Right, where's the other bugger? There. Cack-handed. Right. Hold on. That's just. And that's just reading the resistance. Yeah, that's right. 1.2k. Hurrah. That's it. Finally done. Only taken me a week of mornings. Never mind. Well, this fault, this delay fault thingy, is a fault that just keeps on giving. So yesterday powered it up without the amplifiers connected, just monitoring the HT to see how long it took to come up, to see whether it, you know, looked about right. Then as soon as this relay engaged, this fuse here blew. It was a 1 amp time delay fuse, and I have powered it up quite a few times with that same fuse in there. Everything's been fine. So I just put a slightly bigger fuse in, a time delay 1.25 amp fuse, basically because I haven't got any, well, I'm getting very low on 1 amp time delay fuses, and that blew the arse out of it. So looking for faults. First place to look is this bridge rectifier here, these diodes. So I've just got me 2 probes from my digital multimeter set to diode test. Just test the diodes. Test that way, good. Not that way. Not that way. Good. That one's good. Aha! So it looks like we've got a Duff diode, or have we? I shall pull it out and find out. Test it out of circuit. Well, that's the diode removed, and as suspected, it's dead. I will have a look what it's attached to try and find out if there is a difficult load or something. Got one lead to ground, got that other lead just connected there. There's no short to ground, so that's good. Right, let's just yank it all about. So I shall replace it, and hopefully that will fix the fault. Right, are you going to focus, you swine? There is the fuse in question. So power on. Okay, did that just go? I wasn't looking, and I think from looking at the so we're still not out of the woods yet. HT is low at about 260, 270 volts when it should be 500 volts. I'm going to cut it there because I suspect that I have more fun and games to come, and this video has already got, well, I don't know, to the sort of 20 minutes. Everybody gets a little bit bored after that. However, on another score, I've been fixing my motorbike while I've been trying to do this. So work on this in the morning, motorbike in the afternoon. And if you come with me, wobble come. That's the old motorbike. You'll have to forgive the sartorial elegance. So this is the motorbike that I had a crash on, and yeah, I ended up breaking my leg and all that shit. Anyway, look at the videos in the past. Let's see if it will start. Bit loud, isn't it? Nice though. Can't wait to get back on the road. Mind you, I went out earlier on and it was, yeah, a bit discombobulating. Anyway, I'm just going to go and turn it off, put it to bed, and I'll see you back inside. Right, I'll bid you adieu. Thank you very much for watching. Take care of yourselves. Ta-ra for now.